All right. Hello, everyone. Welcome back to the channel. Welcome to TutorHub, your e-classroom on YouTube. So today we'll be learning about empirical and molecular formulas. Okay. So in chemistry, you'll be encountering empirical and molecular formulas very often because you'll be dealing with a lot of chemical substances as you go along your chemistry subjects. So first we define what an empirical formula is. So basically, an empirical formula is the simplest formula for a compound that agrees with the elemental analysis, and it shows the lowest whole number of moles that gives the relative number of atoms of each element present in a compound or molecule. So one example of an empirical formula would be HO. Another example would be CH, right? This formula tells us that we cannot further reduce the formulas or the subscripts of your elements within the empirical formula. So H in HO has a subscript of 1. Okay, so if you don't have any subscript on the chemical formula, it's understood to be 1. Whereas oxygen here doesn't have a subscript, it also has a subscript of 1, right? The second example, CH, also doesn't have any subscript for carbon and hydrogen. So we know from assumption that your carbon and hydrogen has 1 as their subscripts. Another example of an empirical formula would be SO2 as well. So in this formula, sulfur has a subscript of 1. It's not written, but it's understood to be 1. On the other hand, oxygen has a subscript of 2. So that would be an empirical formula because you cannot further simplify this formula by dividing the subscripts with a common factor. On the other hand, your molecular formula shows the actual number of atoms of each element in a molecule of the compound. So the molecular formula, say for example, of hydrogen peroxide is H2O2, right? So within the hydrogen peroxide formula, we see 2 hydrogen atoms and 2 oxygen atoms in the molecule. And because you have 2 as the subscripts of your hydrogen and oxygen, we can divide them both, the subscripts of both atoms, by 2 to get the empirical formula HO, which we have here in our previous example. Another example would be C3H6, right? So C3H6 will be a molecular formula of a compound with 3 carbon atoms and 6 hydrogen atoms, right? So if we divide this molecular formula by 3, which is a common factor of the subscripts of carbon and hydrogen in this formula, then we can come up with CH2 as the empirical formula of that particular compound. Another example would be S2O6, right? So if you have S2O6 as your molecular formula, you have 2 sulfur atoms, right? 2 sulfur atoms and 6 oxygen atoms. And if we divide the subscripts by 2, we have the SO3 as the empirical formula of this compound. So if that's clear, like this video, click and put a thumbs up on the comment section so that I know that you are still with me and that you're learning so far, right? So at this point, let us have some calculation problems so that we can demonstrate how to solve empirical and molecular formula questions. So let's take this particular example where a certain compound contains 0.21 moles of zinc, okay, 0.14 moles of phosphorus, and 0.56 moles of oxygen, right? And you are asked to determine the empirical formula, right? So these are your given information, and this is the required information from you. So how do we solve this particular problem? So our solution would begin with our knowledge that the subscripts of the elements in a compound are actually the mole ratio of the elements present in the compound. So what we usually do is we make a table of the elements in the first column, and then we write them down. Say this is zinc, we have phosphorus, and we have oxygen. Then on the second column, we have the number of moles of each of the elements. So based on the given, we have 0.21 moles for zinc, 0.14 moles of phosphorus, and 0.56 moles of oxygen. Then we divide each of these values by the smallest mole value among the elements that are given. So if you look at the given value of the moles of each element, you have 0.21 for zinc, 0.14 for phosphorus, and 0.56 for oxygen. So among the elements, phosphorus has the smallest value among them. So we divide all of the mole values by 0.14 moles, which is the value of moles, which is a mole value for phosphorus. So we put that on the next column, divide by lowest mole value. Okay? So divide that by 0.14, divide by 0.14, divide by 0.14. And so we get our answers here. So 0.21 divided by 0.14, that's 1.5. 0.14 divided by 0.14, that's 1. And 0.56 divided by 0.14, that's 4. Now this ratio will actually now become the subscripts of our compound. So that would be zinc with a subscript of 1.5, phosphorus with a subscript of 1, and oxygen with a subscript of 4. However, we cannot have decimals on the subscripts of the elements that we are considering. So we need to think of a factor that will make the decimal, the smallest factor that will make the decimal value of the subscript of zinc as a whole number. What would that factor be? Very good. So that would be 2. So if you multiply the whole formula by 2, we now have zinc 3 P P2O8. So Zn subscript 3 P subscript 2O8 would now be the empirical formula of this particular compound. Okay? Is this understood? Right. If you have any questions, you may type it on the chat box and I'll try to address it as soon as I see your question, right? So at this point, let's try another example. What if this time we're given the masses of the elements? So for example, we have para amino benzoic acid, right? Which is found in your bottles of sunscreens, is composed of carbon, that's 61.31%, hydrogen, that's 5.14%, nitrogen, that's 10.21%, and oxygen, that's 23.33%. Okay, now find the empirical formula of para-amino benzoic acid. Okay, so how do we do this? Now, unlike in the previous example, where we start with the number of moles of the elements, here we have the percent composition of the compound. So you have 61.31% carbon, 5.14% hydrogen, 10.21% nitrogen, and 23.33% oxygen. So what should we do first? The first thing that we need to do is, like before, we first construct a table. Okay, so we put the elements on the first column. So we have carbon, hydrogen, nitrogen, oxygen, right? And we place the given, the percent composition, right? Our carbon is 61.31%, 5.14%, 10.21%, and 23.33%. If you add this all together, you will have 100% composition for your para-amino benzoic acid. Now, how do we work from here? Assuming 100 grams compound, so assuming that we have 100 grams compound, then we will practically have, or we will automatically have 61.31 grams carbon in 100 grams of the compound, 5.14% hydrogen in 100 grams compound, 10.21 grams, and this should be grams, nitrogen in 100 grams compound, and 23.33 grams oxygen in 100 grams compound, right? So because we have the percent composition of the elements totaling to 100%, therefore, within a 100-gram compound, you will have this same numerical value for the masses of the elements present within the compound. Now, what do we do after this? So we need to convert, because the subscripts of the atoms in a particular chemical compound corresponds to the mole ratio of the elements in that compound, then we need to determine the number of moles of each of these elements. So how do we do that? We divide that by the molar masses of each of the elements. So we know carbon's molar mass is 12.01 grams, hydrogen 1.01 gram, nitrogen 14.01 grams, and oxygen 16 grams, right? So dividing each of this, we get 5.105 moles carbon, 5.09 moles hydrogen, 0.7288 moles nitrogen, and 1.456 moles oxygen. So now we already have the mole values of each of these elements. Then, like in the previous example, we look for the mole value, the lowest mole value among all of the mole values that we have, and that happens to be 0.7288 moles, which is the mole value of nitrogen. So we calculate the ratio for each of these elements by dividing all of them by 0.7288, 0.7288, 0.7288, and 0.7288. So I hope you have your calculators with you at hand so that it would be easier for you to follow through and calculate the answers. So if we divide 5.105 moles by 0.7288, we get 7.005, which we can simplify to 7. 5.09 divided by 0.7288, we get 6.987, which we can round up to 7. This will be equal to 1, and this will be equal to 2.001001, which you can drop and simplify to 2. So that gives us the chemical formula of para-aminobenzoic acid to be C7H7NO2. Okay? So that would be the chemical, or the empirical formula of our para-aminobenzoic acid. So is that clear? Were you able to follow through and understand how we calculate the empirical formula of our compound? Okay, don't forget to like this video and share with your friends and review it over again so that you'll be able to master this topic. In the next video, we'll have more examples of determining, the empirical and molecular formula of compounds, so please watch out. Thank you for watching TutorHub, your e-classroom on YouTube. Happy learning, everyone. Bye. See you next time.